right, now it's recording. All right, my name is Joseph Haugen,
And I am Carlos Alberto Cortez.
and we did our project on high voltage DC power lines. All right, to start off with, we have a little bit of background history. We have the current war between Edison and Westinghouse in 1881 to 1887. This was a dispute over Edison's DC and Tesla's AC systems. At this time, DC systems were not able to transmit power over great distances without energy loss. It was also too expensive to supply varying voltages to the consumer. The reason why AC systems won at this time was because voltages were able to be stepped up or stepped down using transformers and was able to be distributed at a lower cost using thin copper wire. However, times have changed.
With today's technology, the transmission of high voltage distribution current is possible to enable energy in both directions. There are two main elements of high voltage direct current. The converter station, which is located at the endpoints of the transmission system, and the transmission lines. The converter station is comprised of inverters and rectifiers to make possible the transmission in both directions. And we use transmission lines, overhead lines. The most important part of the converter station is the bridge converted unit and the converter transformer. The bridge converted unit is built by a controllable semiconductor ball of tri-resistors in series and uncontrollable semiconductor ball built of diodes. Next slide. This is an example of the 12-pulse bridge converter with two transformer secondary sides. Next slide. This is an example of the transmission link between France and Spain. That's a real converter station used to supply energy between these two countries. Also, the modern high voltage DC systems are introducing the pulse width modulation, which includes insulated gate bipolar transistors, which make it possible to regulate any frequency and amplitude by changing the PWM signals. That will make blocking voltage capability from 6.5 to 8 kV with a maximum current of 3.6 kiloamps. High voltage DC transformer are the main supply voltage value for the bridge converted input and is designated by two three-phase voltage system shifted by 30 degrees, and it uses two types of winding configuration, Y-Y connection and Y-delta connection, to make possible to eliminate the 5th and 7th harmonic from the AC side and the 6th harmonic from the DC side. Also on the high voltage DC current, they've been using AC filters, DC filters, surge arresters, and disconnectors. On the side, we had an image of the world's first 1100 kV transformer developed in Germany to be used between Tianjin and Wuhan in China. To me, this transformer looks like a giant nuclear weapon.
All right, now an example of how high voltage DC lines are integrated is in this example of a wind generation plant. First, wind generated power is transmitted over AC transmission lines, which would then be converted into DC at a converter station to be used on the high voltage DC line. Once it travels over the high voltage DC line, it would then be converted back into AC, which would then be distributed to homes and businesses. Now I'd like to talk about some advantages. Some advantages of high voltage DC is in the decrease in power losses, in which we no longer see any inductances, as well as transmission capacity is used for active power or real power transmission. Therefore, we don't have any reactive power. Another advantage we see is in the lower number of lines used in transmission, and high voltage DC is more efficient in the use of the cross-sectional area of a wire, uh, so known as the skin effect in AC lines. So in AC lines, as you see on the right, uses the outer circumference versus DC, which uses the whole conductor while conducting power. Now, where another example of where high voltage DC is used is in submarine transmission, such as the North Sea Link, which connects the UK to the European grid. Some disadvantages, however, uh, one would be during inverter operations, which having problems in high order harmonics, power quality, and noise through telecommunication signals. Another disadvantage would be at the converter stations, having large amounts of thyristors, expensive components, and some power losses. Finally, would be its electrical infrastructure, in which it is adapted to AC power for energy consumers rather than DC.
For the economic impact and high voltage DC systems, the high voltage DC are more efficient over long distance and transmitting large amount of power. Also, high voltage DC will give us a lower capital cost, lower power losses, and is more effective undersea lines. The break-even point or critical distance in terms of economic cost occur between 600 kilometers and 800 kilometers for the overhead lines and 50 kilometers on the submarine lines. As is illustrated on the chart, we can notice that after 600 or 800 kilometers, we break even, and beyond that, the DC terminal cost of the DC transmission line will be cheaper than the AC lines.
All right, now I'd like to talk about the high voltage AC versus high voltage DC. In high voltage AC, we have a better protection system. It also has a 0 voltage point in between the positive and negative maximum voltages. It is easier to distribute to consumers. Line conversion is much cheaper uh, due to transformers, and more efficient at shorter transmission distances. On the other hand, high voltage DC is economical and has no technical limits on transmission distance. It uses asynchronous connections. It can carry more power than high voltage AC while having lower losses than AC. It has a much better controllability factor. On the bottom picture, it shows the comparison between AC and DC towers or high voltage towers. In this case, showing that DC uses less lines and occupies less area than AC. So AC uses 6 lines, while DC only uses 2 lines and 1 tower. And then in conclusion, high voltage DC transmission lines is a revolutionary advancement in the improvement of the electric power grid. With high voltage DC, we are able to transfer large amounts of energy over great distances more efficiently and cost effectively. And that is our project.